Hi guys, let me know if you can hear me. Can you write in the chat room whether you can hear me or not, please? Okay, cool. We have 4 more minutes to start. Let's wait for some more people to join. Three more minutes to start the stream. Okay, guys, it's time. It's 9 o'clock Eastern Time, 2 p.m. UTC. Um, so let's get started for today's session. At any point of time, if you are not able to hear me properly, there is some background noise or something, just let me know. I'll try to adjust the settings, right? So let's get started. This is the agenda for today's discussion. Today we are going to talk about credit smart contracts and how they can be used to mitigate some of the problems we currently have in our traditional systems. The agenda is going to be a brief introduction about me and problems with the current traditional systems. When I say traditional systems, it's not about Ethereum, it is about the non-blockchain based software applications. What are the problems we are facing there? And coming to the blockchain, what is a smart contract and how they can be used to resolve some of the issues we have in the traditional systems. And then we will talk about the advantages of using credit smart contracts over the other smart contract mechanisms like Ethereum or EOS, and then write some simple smart contracts using web wallet in credits blockchain. And for the hackathon session, I'm building the blackjack game, which is popularly known in the casino industry, on credits blockchain, and I'm going to explain what are the advantages of doing so rather than going in the traditional way. And I will show some example, a sample code of what I'm doing. I'm not fully done with that, so it will be like a theoretical session on the blackjack game and what is going to be done there. The whole code will come in the next session where we will be discussing about the DApp development of DApp development in credits. So we will present the whole use case there, right? So let's get started. About me, I am based in Atlanta, Georgia, United States. I'm working as a solution architect for a multinational company right now here. I have about 15 years of experience. I started my career with IBM, and I worked in different sectors including telecom, insurance, logistics, airline industry, and retail sectors. This is my Telegram ID. Feel free to reach out to me if you have any questions, even after the stream. Um, Now, let's talk about the traditional way of doing things, right? Let us take any example like a ticketing system or a online blackjack game, because that is what we are going to discuss anyway further down the line. Um, so, I hear the sound is shifting from high to low. Let me see. Um, okay, I just moved my mic closer. Let's see if it resolves the issue. The problems with the traditional systems, right? The trust, reliability, and central control. When I'm talking about trust, let's say if we are hosting an online gambling game, right? For example, blackjack. Now, if we want to host that in a traditional fashion, we are going to host the code in a AWS instance or something. And then when we want to play, we have to trust the source code. Like they are actually generating the cards randomly, and they're being shuffled, and you are not getting more than twice the same card from the same pack. When I say pack, normally in the blackjack game we use two sets of cards. So it is possible to have two diamond nines, right, in the whole stack. You cannot have more than one, right? More than two. So basically, we have to trust that system whether it is actually generating the randomness as we need or not. So that's the reason the gambling is not so popular online, because of this trust issue. And the second problem with the traditional systems is the reliability. As you know, most of the organizations they have either the private cloud or we call the public cloud, right? When I say public cloud, it is like AWS or Amazon, Azure or Google Cloud, right? So it is a single point of failure. That means if the data center goes down to fail over to a DR data center, it is going to take time. Or right, simply put in a way, it is a single point of failure system, right? And that is one problem with the traditional systems. That's why you see outages like when Amazon goes down, AWS goes down for a couple of hours. You know how much millions of dollars were lost to the businesses, right? So that is where the reliability comes into picture. And then the central control, like a government wants to shut down, let's say, Amazon for something. All the instances on the AWS, if they were brought down, then the organizations will be in big trouble, right? So, and also if you are hosting a site and governments or some entity wants to take that down, it is possible because they just need to hack into one system, or they just need to regulate one company, right? So these are the problems the blockchain industry is trying to solve. um, and how they do it is using the concept of smart contracts introduced by Ethereum. Initially, Ethereum is the big brother for all these smart contract technologies, as you know. In a layman term, what is a smart contract? A smart contract is nothing but a piece of code that is immutable and publicly available. So that means when you write the smart contracts, you have to get it right the first time itself, and because it is immutable, you cannot update the code, you cannot maintain the code, right? And it is publicly available. When I say that is where the trust is going to be solved, because the source code is publicly available. Anyone can audit the code and see if it is all okay. It is not doing any favor to the hosting application, right? So you can actually read through the code and you can trust that one, right? And then the decentralized part of it is going to tackle the centralization problem. That means all the source code, all the account details, everything is going to be distributed among the nodes throughout the world. So there is no single point of failure, right? And some of the use cases currently the smart contracts are being used are for escrow, ICO fundraising, and DApp development. The escrow talks about um, um, uh, the agreement between the seller and the buyer, right? So when you're buying a house, this escrow term you might have heard. So before the property is transferred to your name, the accounts what you are sorry, the amount what you are willing to pay, and is going to go into some account called escrow account, and once everything is finalized, the amount is going to get released to the seller, and the property is going to be named on your name, right? So that is where the escrow normally uses. So here we typically use some third party companies or third party law firms to maintain this escrow account, and subsequently transfer the ownership of either the fund or the home to the intended user. Smart contracts can resolve this issue by removing these third parties, and you write a smart contract um, and effectively deal with this problem, right? And then ICO fundraising. So Ethereum smart contracts are well known for this one. So wherein you are sending some given amount of ether to that account, and in return you are going to get a specific number of other tokens to your account, right? So basically for fundraising we are using. So it is basically a piece of code that is going to accept Ethereum and convert into number of tokens that the smart contract is going to give out, and then send those tokens back to you, right? And then for the DApp development, this is the core concept of smart contracts, wherein the code that you want to be trusted, and you want to be publicly available, you want to be basically the code what can be visible to the public. You're going to put it on the on as a smart contract, and you're going to access it from any front end application, right? So front end always talks to this smart contract, and the front end is not going to do anything other than the presentation layer, right? The whole implementation part of it is going to reside on the smart contracts, which you can audit at any point of time, We discussed about the smart contract now. Let's talk why not Ethereum. Ethereum is already providing all these solutions what we just spoke about, and why not Ethereum? Why credits, right? The reason why Ether was not able to be adopted as of now is because of its slow speed. Um, because of its slow speed and difficulty of development with the programming language Ethereum uses called Solidity, right? So Solidity is a very high level language which has a limited functionality what you can do with it, right? And then the high cost of transactions. I don't know, I'm not moving my head. I'm just staring at the laptop only. I don't know why the sound is high and low. Is it too bad, guys, or okay? Yeah, I'm just speaking a little bit louder now. Maybe that will help. Right. So now uh, the problems when we are talking about Ethereum is the slow speed and the difficulty of programming the smart contracts because of its language that is being used, which right, and then high cost of transactions. Um, Right. So now let's talk about Credit Smart Contracts and how it is going to solve the problems that Ethereum is facing and why it is advantageous. So the first, the main reason I am so interested with credits is because of its development language behind the scenes. It is Java. So um, basically, Java is the most popular language out there, and many of the production systems are developed in Java. So when there is a possibility to convert the existing code from the centralized system into decentralized system, when it is Java, it is easy to port that code, right? Because you already have the code in Java. It is easy to port into the blockchain because here also we are using Java only. There may be a learning curve involved, but it's not going to be as steep as Solidity, right? And then high transaction speed. The credits, as we have seen, it has already demonstrated that it can scale up to 1 million transactions per second and a stable 100,000 transactions per second. Think about it. 100,000 transactions per second itself means but 10 times what Visa is currently handling, right? Visa at one point handled maybe 24,000 transactions per second. But traditionally, are on the regular basis, the stable load, what you say, is about 7,000 transactions per second, right? So 100,000 stable speed itself means it is more than 10 times the speed of Visa. So 10 Visa type of companies you can host on smart contracts at this point of time without even reaching 1 million transactions per second stable, right? Let just sink in for a second about these speeds. These are astronomical speeds, right? So that is one of the main advantages of credits. And then the disadvantage of having Solidity is this autonomous smart contracts, what we call that, right? So a smart contract has traditionally has to be invoked by a third party always, an API always, right? It cannot execute by itself. Whereas credits is going to solve that purpose by giving us an event-based scheduling option. We are yet to know the full details about this one. Credits is planning to release this information in the near future. I mean the whole description of how to do that, right? And then the API support to deploy. So this is one of the main reason why the credits can be a successful blockchain platform is because of its API support. With the APIs, it is possible not only to call a smart contract but also to deploy a smart contract. So in the traditional world, we have something called DevOps, right? Wherein wherein you write a piece of code and there is an automated program which is going to deploy that code into production environment at a given time. When you have this API support, it is possible to develop these DevOps scripts to deploy that smart contract. So the deployment of a smart contracts on Credits platform is going to be a piece of cake, right? And then another thing is Credits is promising that the transactions cost cannot exceed like 0.01 of a dollar, irrespective of the load at that point of time, right? Because in any way Credits can handle thousands or even millions of transactions. There is no kind of gas war, right? I'm okay to pay more gas to get this transaction completed in Ethereum. You don't need to do that in Credits because it can process n number of transactions or any number of transactions that you can throw at it, right? Okay, so now let's talk about smart contracts, the theory behind them. The credit smart contracts, when you're trying to build them, the class name has to be always contract, the main class name. You can have classes within the classes within this class, but the main class name has to be always contract, and it has to be extended from a smart contract class, right? You can write one or more methods inside this class, just like any other class, and you can define some variables in this class, and you want to access them publicly in all the methods that you're defining in this class, right? I will show examples of them in the later slides. So methods can take one or more arguments, as we know, and um, the commands are the code that you are going to use within a smart contract is not going to be limited by the by the language that we are using in a smart contract, because it is Java. You can use any of the Java functions that you can think of and write your code. Basically, it is as simple as porting your code from your existing application to this one. I have tested this one where we can use java.util package in the smart contract. What this gives us is ability to use stacks, vectors, right? This kind of stuff. There are so many other classes that you can get from java.util package. I didn't try for any other package, but I know we can be when we can use java.utils, why not the other packages, right? So you can use other packages that are by default available with the Java 1.8 version of version, right? So now let's try some examples. The first one is a simple example. Let's try to add two numbers. Let me see if my node is fully synced. It is not. I was playing with this node just before we start the session, so I have two nodes just to be on safe side. Like if one goes down, I can use the other one. So let's try from the second node. Right? You know about this web wallet, and just keep in mind this web wallet is going to be rewritten completely into into I don't know what they're going to use, but it is going to be improved much better. We have seen Credits website and it is so professional, and the wallet is going to be something like that. It is going to be as professional as Credits website itself is, right? So you click on smart contract and you come here. So let us try to create some contract to add, let's say, two numbers, right? So as I said, public class contract, this is the name of the main class, and you cannot change it. If you type if you try to edit it, it is not going to accept it, and it has to be extended from a smart contract. And Java doesn't support multi inheritance, so you cannot extend this contract class from some other class of your choice. So it has to be always one class from which you can extend. So that is going to be smart contract. You cannot change anything from that, right? So now we are going to say add two numbers, right? So let's call this method as add numbers, something like that, and then it is going to accept two parameters in let's say number one and in num2, right? Two numbers, and we are going to return the sum of them. Let's say it is going to be a long, right? So the return type is going to be long. So let's define long total equal to num1 plus num2, right? This is what we are going to return. A simple method just to add two numbers to see how we are defining the method, how we are returning the values, and how we are taking the parameters to that method, right? So now we do a quick check. It says everything is okay. The check is just going to check whether the braces are closed properly or not, or semicolon is there or not, kind of things. It's not going to do much validation as such at this point, and I think this IDE is going to be improved further. And say deploy now. Okay, missing return statement. You see, it didn't give this error when we did say check, but when we try to deploy, it is giving that error. Right? So let's add that return statement. Right? Say quick check and say deploy. Okay, so smart contract has been generated properly, and it is copied to the clipboard. So you just say go back, and you can search for that contract using this one. Automatically this will be available in your personal contracts because this smart contract has been created from this account. It is already available here in your personal contracts, but you can always search for the smart contract using the address, right? And now when we try to execute this smart contract, it is going to ask which method you want to call. So add numbers is the method name that we have defined, and it is going to ask for two parameters, num1 and num2. So let's say num1 is let's say 4 and num2 is let's say 5, right? When we try to execute this one, what did I do wrong here? Okay, you see, I created the smart contracts from the other node 1, and now I am in another node, and we can see that the smart contract is already available here, right? Let's try to execute from here and let's see what's wrong with this one. Okay, it is giving some exception. I don't I don't know what's wrong with this one. Let's try to create one more. I'll create from here. Is it because no, you can always add int and come back with, let's see. Guys, I don't know what's going wrong. I tried this one, it was working fine. Okay, let's see. I will dig through this one. What's going wrong here? I don't understand. And then the next then the next example I want to talk about is the loops using a for loop in the smart contract. I just want to loop 1 to 100 numbers and then get a sum of these numbers, right? Let's see if we can execute that one. I already created this contract somewhere. It is ending with FU7. So let's open FU7. So if you see, this is the source code. I'm not accepting any input for this one, and it's a for loop for I equal to 1 to 100, and return total is equal to all the numbers 1 to 100 numbers, right? Let's try to execute this one and see. Yeah, you see, I'm getting the value properly here. So I don't know what's wrong with the old smart contract. I'll just go through that one more time, right? So basically, what I wanted to show here is we do support the looping, so you can play around with this one. The one thing what you need to what you need to make sure when you're writing a smart contract is it has to be efficient. There can be some try to save the old one with a method name other than the contract. It's not needed. I tried multiple method names. You see here, the method name is return sum of 1 to 100 numbers, right? So the method names um, need not be just contract. You can do anything. I tried with this one. I will see. Maybe I'm doing something wrong there. I don't know what's that. Um, right. So this is just to explain the loops within credits, and then I'm going to show you some example of how to use the packages. So I have already created this one for the create stack and operate stack is HNR, something like this. So you see the smart contract here. I'm using java.util.stack. One thing I observed is normally in the Java world, if you just use stack, it already knows because you have already imported that package upfront, right? Here there is no import statement that we can give, so you have to prepend it with the full path of the class name. So java.util.stack s is equal to new stack. I'm going to create a stack which can be used in all the methods inside this class. I don't know. I don't know. Okay, so now the first method, the first operation in this class is push to stack. It is going to accept one string element, and then it will say yes dot push. So we are pushing that element to the stack, and then return that element back to you, right? And then pop from stack. You know about stacks, right? It is queue. I mean, you push the message and take the message what you recently pushed, right? So pop is used to take the element out of it and then get size of the stack. So s dot size is going to give you the size of the stack, like number of elements it has. So let's try to let's say push a number. Let's say a. I'm pushing. So it says A is pushed to the stack, right? And now let's say B. I'm saying B is pushed to the stack. Now let's try to get the size of the stack. It is 2 because we pushed A and B to it, right? And now we try to pop pop from, I mean, take out an element from the stack. So A is pulled from the stack. If I still has two. Let's see if I'm getting some exceptions here as well. I don't. A is pulled from the stack. Execute one more time. Okay, so I don't know what I did wrong here again. Why the pop is always giving the same value? I'll check about this one. The reason why, yeah, I'm just using the laptop mic, man. I don't have the professional mic with me. Right, so just bear with me. Right. Um, right. So the reason why I played with these stacks is because I wanted to use this functionality in the blackjack game, what I'm trying to build. Let's talk about that part now. Right. So let's talk about this one. What I'm building now. The blackjack game. What we're going to build. It's one of the popular game in USA casinos. So basically, statistically, the the blackjack game gives 51% probability of winning for the player when you play the game per the rules, right? Like 4 5 6 as the burst cards, and you are not going to you're going to play safe when the dealer gets 4 5 6, right? And you're not going to hit after 17. So if you just play by the rules, it is 51 probability, and if you play with your guts, that matters, right? So this 51% is going to be a difficult number to digest, because even if you are playing this game online, right? If the online system is written to give at least 2% favor to the dealer, then the probability of you winning is not 50%. It is less than 50%, right? So it is going to lean towards the dealer than you. Right. So even if you try to play the game and it looks like everything is fair, even that percentage, the 2% thing, what they do is going to make the difference, right? So it all comes to the probability, right? um, so we cannot trust the online game because of this reason, right? So now how we are going to build this game and create this blockchain is, we are going to use a front end based on Java, but you can use any of the front end. You can host it online using Node.js or Angular, or any a JavaScript type of language, because the front end is going to be just the presentation layer of this application, whereas the whole logic of the game is going to present as a smart contract in the blockchain, right? So yeah, I don't have the proper mic. I'm sorry. So now the whole logic of the blackjack game is going to reside as a smart contract. So it is publicly visible, and you can see that there is no bias that the dealer is going to get, right? The front end is just going to display the results in a user friendly manner. That's it. It's not going to do anything. So in this game, what we are building, it has like this player details page, wherein you enter your username, your public key and private key. I just named both of them public key. Sorry, right? And so when you start the game, it is going to check this wallet and see how much balance you have at that point of time. And then if you see here, the balance what you are getting is 100 is what the balance you have in your account, and depending on how much balance you have, these buttons will be either enabled or disabled. Like now, because you have 100, you can place the bet of 100, or you can place the bet of 25 or something. once you place the bet of say 100, then all these buttons will get disabled so that you cannot bet anything more than that, more than what you have, right? Um, um, right. So once the bet is placed, a call will be made to the credit smart contracts. Okay, now the bet is placed. Give us basically one card to the user, one card to the dealer, and one card to the user again, and one card to the dealer. But the one card what is given to the dealer is not displayed here. Basically, this card is not going to be returned by the smart contract itself. The front end doesn't know what the fourth card is at this point. Only the smart contract knows what that fourth card is going to be, right? So now, when we say hit or when we say hits, let's say, then a call will be made to the smart contract again to get another card to the user until the user says user is either burst or he stays stand, right? And similarly, if you are saying say double, then whatever the bet you have already placed, the same amount is going the double that amount is going to be transferred again to the smart contract, and it will be held there until the game is finished, right? um, so once that is done, the smart contract itself is going to give back the card what dealer had initially, and then also play the next game for the dealer automatically. It is not going to display you anything, but it is going to automatically play the game and give the result and transfer the funds to whoever wins, right? If the dealer wins, the the, um, the generator of the smart contract, which is going to be me, will get credited with that amount, right? Whereas if the user loses, he is going to user wins, the amount is going to be transferred from the dealer's account into this one, right? And the smart contracts will also ensure that the dealer's account also has the required funds available, right? So now the difficult part in this, or not the difficult part, to make it actually proper. Normally, if you want to get a card, right, you just generate a random number and divide it by 104, right, the number of cards in this one, and then decide which card to give. But that is not how the blackjack game actually will be played. You have to make sure that you always have only two diamond eights in the stack or two heart six in the in the stack, because it is a two pack game, right? Because if not, the probability or your rules, everything is not going to come into picture. So all right, let me try to show you that game, and maybe you will get some better understanding of the complexity of the game itself, right? So I'm not done with the development of this game completely. So as of now, I have some trouble invoking the credit smart contract. Basically, it is not like invoking. When I'm trying to sign the transaction, I was not able to do that. I am seeking help from credit's dev team for that. Right, it will be ready before the next session, basically, right? So this is how the player details, in the player details you are going to enter the public key and private keys, and you can pet as of now, $100 balance is there, so you can place the bet of 25. And now if you see this 100 is disabled now, so you cannot place the bet of $100 again, because you have only $75, right? So 75 credits basically. I have placed 25 bet and then say $10 bet, so total $35 I have placed, 35 credits I have placed as the bet, and say deal. Right, so it is going to give one card to the user, one card to the dealer, one card to the user, and another card to the dealer with face down, right? So now credit user has 20, it is a good number. I'm going to say stand, no, I don't want any more cards, right? And the dealer has 22, so dealer is burst, so the total has to be less than or equal to 21 always, for either the user or the dealer to be in the game, right? So now I won this game, so the $35 has been deposited to my account.
right? And if you see here, the deck 98 of 104. So the deck has only 98 cards now out of the previous 104 cards. So whatever the cards you got on this game, on the first game, you are not going to get it again. I mean, you will get another six hard, but you are not going to get it again. You see what I'm saying, right? So now I'm going to place the bet of another $10 and say deal. And now again I got 20. It is a good number. So I'm going to say stand. Again I won, right? So my balance has been increased. I don't know why I'm winning always. So 14, but the dealer has 7. 7 is not technically a burst card. 4, 5, 6 are supposed to be the burst cards. So the rule says I have to hit. So I'm hitting. So now I'm getting 23. It bursts. So I lose that $50, right? So basically, you understand what this is actually doing. So basically, in this one, we have a card pack. Pack has 52, and it is going to use the stack of again card can be either one of the 4 different types: heart, diamond, clubs, and spades, right? And it is going to have a maximum of 52 in one card pack, and in the deck you are going to have 2 stacks of that cards, right? So basically it always makes sure that you are having that 1 or 2 number, and after a given um, if the card is empty, if the stack is empty, then it is going to shuffle. Or if the somewhere the logic here wherein if the number of cards available are less than some given number, let's say 25% of that 1 or 2, then we are going to shuffle. That logic is going to be there in logic is going to be there in the smart contract, right? So that is how the game will be played, right? So I have no more slides to show. So so any questions as of now? Guys, let me know if you have any questions that you want to ask about the smart contracts. When mainnet, IBM, I don't know all these things. Right. A few more things before we wind up. I wanted to discuss because I'm not getting any more questions that I must answer. You might wonder, like, if you are having a Java application, right? You are running this application and you stopped it and you restarted it. Whatever you have saved in the memory of the application is going to be erased, right? Because these are volatile memory, what we call it as. So once the machine gets restarted, you are going to lose the data. But how come credits is able to keep track of all of them? I mean, what operations you did on one node are going to be reflected on the other, and when the node gets restarted, how it is going to get all this data back, right? It is This is how Ethereum does it. Each transaction that you are going to execute, or each operation you are going to execute on the smart contract, is again a transaction, right? So these transactions are already recorded onto the blocks of the blockchain right? So when you restart the node, when it is actually reading, when it is actually getting the blocks from the other nodes, basically in the memory it is going to execute all those operations, and so it maintains the state of the class. an instance of the class, once it's generated, it is getting updated because you're calling methods inside that class, right? So that is how I mean the values of the constants in that class are going to be maintained, right? Because if you see, I have used stack, right? I pushed some elements to it, and then I shut down my node, and when I restart the node, I should get all the elements that I have already pushed, right? That and it has to be the same across all the nodes. A consensus will be there about the return value of the smart contract. Once all the smart contracts are the majority of them in the trusted nodes is going to give the same result. It is going to be display, right? So all this is going to happen behind the scenes without us knowing, right? And at the lightning speed, right? First two cards are open and not blind. I saw your first blank card was blind. Is that the rule in Russia? No, I'm not from Russia, so it's not. When I play the blackjack, the first two cards are open and not blind. Yes, the first two cards are open, what the player gets. And the only one card of dealer is going to be shown. The second card is face down, right? Right. If I say deal, you see two cards of the user are face up. You can see them, and one card of the dealer only you can see them. The other card you can't see, right? Until you are done with your game, the dealer card is not going to be displayed. And also, if the dealer has blackjack, I mean K and A are something which already results in 21 count. Dealer cards are both shown here. No, that's not the case here. At least in USA, that is not the case. I know for sure. Right? Robert, where are you from? I mean, which country that rule? Okay, yeah. So, oh, Netherlands. Okay. Okay, so there is no insurance logic in Netherlands. Then in that case, right? So here normally what happens is if the dealer gets an A or K, sorry, I think A's only. Then dealer gives us an option to take the insurance. Like if he gets the blackjack, then you're not going to lose the whole bet amount. You're going to lose 50% of that amount, something like that. And if the dealer doesn't have the blackjack, then he will take that insurance amount as well. So that's how it is played here. Maybe I should implement that insurance feature as well, just to make it more realistic. We will see. And by the way, the whole code I have not developed on my own. I took pieces of this code, not pieces, most of the code from a GitHub repository by someone else. I'm just changing it according to our use in the create smart contract, right? Any more questions, guys, about the smart contracts? And by the way, if any one of you are from Atlanta area, feel free to reach me. Feel free to reach me. Maybe we can sit for drinks or something, right? Okay, looks like we are not getting any more questions related to smart contracts anyway. So the session is planned for 1 hour. Guys, the live stream is still on, right? Arsenis says he is not able to see the stream. So I'm just wondering whether you're able to see. Okay, yeah, thanks, Robert. Okay, guys, I think I'm not getting any more questions related to smart contracts. It is much easier than what I anticipated. I thought I will be bombarded with many questions about smart contracts, but looks like not so many technical guys joined, but that's fine. Let's wind up the session for now, and thank you for joining. See you in the next session. Okay. I will be releasing this game as a jar file. You can just run it on your local machine when you have the node running, and you can just play by yourself. Right? It is not going to be done right away. It is going to take some more time. Thank you, guys. Right? I'm ending the session. Thank you for joining.